Hello friends, this is Daniel, and I'm back on here to do another popular LeetCode question called Count Primes, which is in the math category on the website. And this problem asks that you count the number of prime numbers less than a non-negative number. In the example, they give you the number 10 and the output is 4. The reason for that is because this question isn't asking you to return the values, the different numbers that are prime. It just wants you to count how many of them there are. So with that being said, we can go ahead and get started. And so my approach with this one is going to be um, a little bit more modular. I think it's easier to explain the problem when I use a helper function. But before I do that, the first step that I'm going to do to make sure that we don't forget what we have here or what we need to return is I'm going to create a variable in our count primes method, and I'm going to call it a counter. So let's go ahead and create counter and initialize it at 0. And we know at the end we're going to have to return the counter. And this just refers to back when I mentioned that we need to increment by 1 for every prime number that we find. So before we continue with our main method, our main count primes method, we can go ahead and create a helper. And I'm going to call it isPrime because this is the one that's going to be checking to see if a number is prime. So I'm going to do private boolean. It's going to return a true or a false. And we're going to call it isPrime. And it's going to take a number. So not to get confused with the number we get passed in, I'm just going to go ahead and call it number. And in here, I'm going to do a quick check to make sure that we test for the constraint, which says that we can't have a negative number. And also we know that 1 is not a prime number. So let's go ahead and say if number is less than or equal to 1, we can automatically return false. We don't have to keep going. If it's not already false, then we're going to go ahead and get started at 2 since we already checked for 1. Let's go ahead and do int I equals 2. I times I uh, is less than or equal to number because we do want to check uh, for the number itself. We're going to increment by 1. And in here, what we're going to do is we're going to check if uh, number, we're going to check to see if it's even. So let's go ahead and do number modulo I equals 0. We can go ahead and return false. All right. And then otherwise, we can return true. All right. So that basically handles our isPrime logic. So now what we can do is call it in our count primes method. So I'm going to say if isPrime, and we're going to pass in I. In fact, before that, we should probably loop through it so we know what I is. Here we're going to start at 0. I is less than n, I plus plus. All right. So here we're going to do our check. All right. So if is prime, if I is prime, we can go ahead and increment that counter that I mentioned earlier. Otherwise, uh, we don't increment, and we want to return our counter at the end. So let's go ahead and run this. All right, cool. So it's not the fastest solution, but this should give you an idea that you do want to check to make sure that a number is prime first, and then go ahead and increment that counter. Let's go ahead and submit. All right, so we got the right answer here. It's accepted. Runtime isn't great on this one. We can optimize this one further. If you liked it, please hit that thumbs up. If you understand it better, go ahead and subscribe to the channel for more solutions. So thanks for watching, and I will see you in the next video.